Hello, good evening. I am George Swaperi. Good evening, Sir Orvin Llantos, our instructor in computer simulation. Okay, I will presenting the project entitled Simulating Robot Groups with Elements of Structure Using NetLogo. Okay, the rationale of this project is the main task of the group of robot is to construct such of such as a system that will give new qualities and improve characteristics due to the interaction of many individual agents possessing relatively simple rules. The main methods of this study is to study this system is simulation and agent modeling for which different environment and libraries of NetLogo. Okay, the objective of the study is to design a certain feature of agent system in general and their implementation in the form of library, and to create a concept of an agent interaction between an agent, the environment, space, and time. Okay, and also to design a model with several interaction group of robot and to create a collision, an instant of moving of object striking violently against another, and to create a placement of action putting something in a particular place using the drag command in the program of NetLogo. Okay, the area of the study is to interface and programming using NetLogo. Okay, the output of this NetLogo program. In this event, I set a number of obstacle 6 and a number of robot 10. Then the robot will move simultaneously and they will move randomly based their actual coordinates. Okay? And by clicking the setup random in the program NetLogo, then the obstacle and the motor of the robot appears randomly. Okay? Now, the related study, the Gazebo is a program that has a set of libraries that allow one to simulate the behavior of robots with regards to physical effect. Now, the capacity of the simulation system can be expanded using readily available plug-in or by rating the new plug-in or by adding infrared or fingerprinting and video camera or by physical effect of movement through a liquid. The gazebo is purely suited for simulating system with a large number of agents. Now, because of the rather high computational cost, the gazebo is difficult to modify model more than 100 agents. Now, the methodology of the study, the program testing during testing this system. Now, first we will set up the random command for the program. Then we will initialize the program will initialize the distance randomly and also the robot from the obstacle. Now, in the given random, the flat surface in this program, we considered that the surface of the area is flat. Now, I conducted a first trial in a total of 6 tests to evaluate the robot collision avoidance program with the results shown below. Okay, I already made a table for these 6 tests. Okay, now the first test and the second test, the robot did not hit the obstacle. Then I changed the codes to avoid the obstacle, and then the robot continues running in the succeeding test of the program. Okay. Now, software development, I use the NetLogo program. Okay, in the flow chart, okay, from the start, okay, the robot initialize the sensor, okay, and the motor of the robot and the motor driver. Now, in the actual view of this robot simulation, the robot read the obstacle, then I give the distance less than equal to 20 centimeter. Then if the robot will detect the obstacle, then the if no, then no obstacle uh, hit by the robot. Then if yes, now the robot will read the obstacle, then the robot will either look left and right, then it will go nearest to the area. Then the wheel or the uh, wheel strafing then will go left or right. Then if the distance is less than greater than equal to left or right, then the 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 robot will go ahead then straight to the another obstacle. Okay. Now the in simulating the program, okay, I set the uh, setup. Okay, the program will give a random, or first you will set how many obstacle you will place in the program. Then automatically the robot also display as for robot. Okay. Okay. Conclusion and recommendation. Okay. Further study, the future of the study is to develop the system to fully implement and support for parallel computing and a test in the computer cluster. Okay. In future, much better if you will by cluster. Okay, by cluster, you in place your robot in cluster, and the total more library in running the net logo. Okay. A conclusion. Okay, simulation system using NetLogo was developed and tested on the same representation group of robots problem. Okay, and validated and programmed. Therefore, I conclude that using this kind of simulation, we need to uh, portability. We need the portability of the code model elements between the simulation and the real robot. Okay. Now let's try to run the program. Okay. Now first you will assign a number of obstacle. Okay. Example, we will assign 8 obstacle. Then you can select the or count the number of robots. Then by clicking the setup periodic X, okay, automatically the program will set where is the value of X. Okay, siya na, the program will set where to in place the uh, obstacle and the uh, what you call this, the robot. Then automatically the number of obstacle is only one. Okay, then if you will set up periodic quilt, okay, the place of quilt is at the upper portion. Okay, and the number of obstacle is automatically will select one. Okay, now if we will set up randomly, okay, automatically, okay, we will adjust the seven uh, number of obstacle. Okay, set up randomly. Okay, 1, 2, 3, 4, 5, 6, 7. Now, if we will click this button drag, okay, we can drag the object, and also we can drag also the four, okay, the four robot. Okay, we in actual you can assign or in place where is the where you can place the four robot so that you can test the testing or avoiding the obstacle. Okay, then also you can trace the path where the uh, robot will go. Okay, first we will offer the trace path. Then click go. Okay, now up. If the object or if the robot will see the obstacle less than equal to less than equal to 20 centimeter, the robot will uh, go left or right rotation so that he can move whatever he can go. Okay, then if we will use the trees, okay, on the trees, okay, there is a line where the robot going and coming from. Okay, we can off that so that they can run simultaneously. Okay, that is all for the net logo. Okay, now the feature of this future study, okay, I already make a IEE format for the project, simulating robot group with an element social structure using net logo. Okay. Now in the future study, okay, I will in the future study or add library for the net logo. Okay, we can add number of obstacle hit by the robot. It will monitor how many obstacle. Then we also count the or we can add number of bounds. Okay, dayon we can count the number of robots. Dayon then we can use the tool. Okay, we can draw a wall or erase the wall or erase the object in the future study of this project. Okay, that's all for the simulation project. Thank you and good evening. Bye bye.